Things are getting hotter and hotter here on Earth. It's getting out of control. So let's try something new. We're going to take all of Earth's water and pour it on the sun. I'm talking every single drop. Maybe that'll cool things down a bit. But is this even possible? Why is getting to the sun so difficult? And once we drench the sun, what would happen to life on Earth? This is What If, and here's what would happen if we poured all of Earth's water on the sun. Okay, before we go about gathering all the water on Earth, shipping it to the sun, and pouring it on top of our burning star, we need to look at the magnitude of what we're up against. The sun is the most massive thing in our solar system, a big ball of burning hydrogen, 1.3 million times the size of Earth. It's so hot that it's like 15 billion atom bombs exploding every second. It's got a temperature of 5,600 degrees Celsius. Okay, it's not actually a big ball of burning hydrogen. About 70% of the sun is hydrogen, and then 28% is helium. The other 2% is comprised of carbon, nitrogen, oxygen, and other elements. The sun is super far away. It's about 400 times further away than the moon. That's about 150 million kilometers away. For reference, the circumference of the Earth is just 40,000 kilometers, so talk about being a long road trip or space trip. And it's no ordinary fire that burns inside the sun. The huge amounts of heat and light that are given off come from nuclear fusion reactions. We'll come back to that later, but this is the fire that we're tasked to put out. It's not just that the sun is hot, it's like a ticking time bomb. The sun is getting hotter and hotter every second. So maybe you're wondering, is that what's causing global warming? Well, no, that's still being caused by us humans and the carbon dioxide we release into the atmosphere. Sure, the sun is getting hotter, but only about 1 degree every 100 million years. Okay, let's be real. Things are getting a lot steamier on our blue marble, so maybe instead of getting rid of fossil fuels, we can just turn the sun's thermostat down. And this is how you're going to do it, by taking all the water on Earth and pouring it on top of the sun. Kind of like the Ice Bucket Challenge, but more of a cosmic scale. Maybe that'll make the sun a little cooler. And if that doesn't work out, we've got one more trick up our sleeve. I'll tell you about that later. The first thing we need to figure out is how much water there is on Earth. 71% of the planet's surface is covered in water, which is about 1.3 billion cubic kilometers worth. That's 554 trillion Olympic-sized swimming pools. Safe to say, that's a lot of water. Okay, so now you've got a handle on some of the awesome power of the sun and the enormous water resources on Earth. It's time to get started. Why don't we test our theory with something a little bit smaller? Instead of all of Earth's water, let's start by shipping just a single glass, about 250 milliliters, 8 ounces. This should be a lot more doable and less resource intensive. Before we take off, the first thing we need to figure out is our spacecraft. For this mission, we're going to be using the Parker Solar Probe. This ship is about the size of a horse and weighs 555 kilograms. Sure, adding a small glass of water to the ship won't hurt. In 2018, the Parker Solar Probe traveled the closest a ship has ever been near the sun. And for this mission, we're getting real up close and personal. Well, sort of. At its closest, the ship will still be 6.2 million kilometers from the sun. Wait a minute, NASA, can't you get any closer? No, NASA says it's super hard getting to the sun. And it takes 55 times more energy to get to the sun than Mars. I'll tell you why in a second. As the probe takes off, the weirdest thing will happen. It'll shoot backward instead of forward. This is because the Earth is traveling very fast around the sun at 107,000 kilometers per hour. To shoot something to the sun, you need to account for the Earth's momentum. So instead of launching forward, it launches backward and ends up going sideways until it reaches our star. Simplest way to think about it is kind of like when you take the wind into account when you're throwing a frisbee. Not that I'm any good at that. Okay, since the probe will take a while to get to the sun, Let's fast forward a few years to where the probe is now in place, as close as it can get to the sun. And a robotic arm comes out, turns the water upside down, right on top of the sun. Well, in milliseconds, with a brief hissing sound, the water just turns into vapor. Absolutely no change to the sun. Well, actually, if we get a measurement from the Parker probe, it seems the sun is a microscopic bit heavier. Heavier? But the sun was going to get doused and get lighter. Okay, well, maybe the probe got the measurements wrong. Okay, time for your second attempt. Only this time, you're going to get serious. No messing around with a wee glass of water. Admit it, that got us absolutely nowhere. This time, we're taking an entire lake from Earth and dumping it on the sun. Let's take Lake Superior. This lake is massive. In terms of surface area, it's the largest lake in the world. In terms of volume of water, it's the third largest. If you took all the water from Lake Superior and poured it over North and South America, we'd all be standing in 30 centimeters of water, 1 foot of water. So how are we going to drain this lake? Well, first, we've got to assume that we've got permission from the federal governments of Canada and the United States. After that's done, we execute. We dig a drainage channel and connect it to a pipeline that'll take it all the way to our starships located at SpaceX headquarters in Texas. Yeah, you're going to need a bunch of those to launch all this water at the sun. But how long does it take to construct a pipeline? Well, it could take anywhere from 5 to 10 years. We don't have time for that. Maybe we can borrow an existing oil and gas pipeline, a pipeline that carries 3 million barrels of oil a day. We could repurpose it to carry the water. Well, let's see, that would still take about 70,000 years to transport all the water. That's a problem. Okay, the pipeline method, way too slow. We need a better idea. What if you used a really powerful pump instead? The most powerful pump on Earth, which you'll import from the Netherlands, the Nijhuis pump. It can pump 1,200 cubic meters a second. At that rate, it would pump 1 cubic kilometer in about 10 days. Then you'll pump the water into huge tanker trucks. The biggest are the large-scale construction tankers. Those trucks carry 227,000 liters of water at a time. Now we got the right idea. So, if you installed this pump on Lake Superior, how long would it take to get all the water out? Well, Lake Superior has 12,100 cubic kilometers of water. Pumping that would take 121,000 days, 320 years. Still a lot of time, but better than 70,000 years, I guess. So, let's multiply the pumps. Let's use 320 of them and cut the time down to 1 year. That sounds like a plan. Even better, if you're willing to spill some cash, we'll build 960 pumps and get it done in 4 months. And then there's another thing we have to figure out. How much is pumping all this water going to cost us? These pumps have to be constructed inside a pumping station, and the construction can cost $1 billion and takes about 3 years. So, building 960 of them? Well, you get the idea. A lot more time and money. And all that construction would definitely mess with the environment and scenery around Lake Superior. You'd probably cause some of the local bird species to go extinct. Getting US approval will be a nightmare, and you'd probably cause an international incident with Canada. But then again, this is a plan to save the world, so hopefully everyone on Earth would get on board. For science. Okay, let's say you do manage to get this done. Somehow then you'll need to transport the water to the launch site using the huge tanker trucks. How many of those will you need? It's going to be 53 billion tanker trucks for all that water. Yeah, that seems pretty unreasonable and likely impossible. Alright, I hate to admit it, but this pump and tanker truck method is going to be a no-go. But you know what? Instead of moving this mass of water from the Canadian border all the way to Texas, why don't we just move the launch site? Launch the water rockets directly from Lake Superior. Building a rocket launch site would take a lot less time and money than moving all this water. We'll pipe the water from the lake right into our starships. That should work, right? If we don't plan on bringing our starships home, they have a payload capacity of 250 metric tons. How many ships would we need to deliver all this water? The answer is, of course, 48 billion of them. Okay, it's going to be tough even to build this many ships, but let's say we did it somehow. Then we'd start launching them from 1,000 rocket sites on a crazy schedule, every 3 seconds, round the clock, for 4 years. But we're going to have to fuel these starships as well. To get to orbit, they use 1,000 tons of methane and 4,000 tons of liquid oxygen. To fuel all these ships, that's 48 trillion tons of methane and 192 trillion tons of oxygen. And we need even more fuel than that to get to the sun. Well, let's just assume that we do it somehow. Our starships are taking off one by one. As the starships get closer to the sun, they're heating up. The temperature in this region is around 500,000 degrees Celsius. The Parker probe was equipped with special heat shield technology, but our starships can't withstand the heat. They start to melt, and all that water, it's become water vapor mist. Darn it, spectacular failure. We were so close. Right, now for a different, outside-the-box strategy. What if we connected a giant hose and aimed it straight at the sun? This is a super advanced mega project that's never been done before, but you're going to do it. This hose has to be 150 million kilometers long, and you're going to make the last 10 million kilometers with special heat-resistant tech so that it doesn't melt. It's not like we haven't learned anything from our previous experiments. It's a little out there, but let's say it works. Okay, Lake Superior is draining into a giant hose. Powered by a massive nuclear reactor, you're shooting all that water from the lake directly into the sun. Since you're doing this from Earth, you'll have to wait to get a reading back from the trusty Parker probe that's circling the sun. It'll report what's going on up there. As the water is hitting the sun, something incredibly strange is happening. The sun is actually burning a little brighter. It's almost as if you threw extra fuel into this fiery giant. What's going on here? Well, to understand, let me tell you a little more about how fire works. We all know what fires are like here on Earth, whether it's a campfire or a flame coming from your gas stove, but these fires work differently compared to the sun. What happens in a regular fire is known as chemical combustion. Carbon in the fuel combines with the oxygen to form carbon dioxide. What's needed for these fires to keep burning are 3 things: fuel, usually wood or gas, coal, plus oxygen, and a high temperature. When you throw water onto these everyday fires, 2 things will happen. 1, the water absorbs some of the heat, lowering the temperature, and the second thing that might happen, well, the water might reduce the amount of oxygen that's available to the fire and put the flames out that way. But the sun, its fire is a little bit different. Even though we call our sun fiery, it's not the same fire we see here on Earth. See, the sun's fire comes from fusion reactions. Billions of them are happening every second. Yeah, a little different from your average campfire. So when you throw water on the sun, instead of cooling it down, you end up giving the sun more power. The water vaporizes from the intense heat of the sun and turns into hydrogen and oxygen, which just so happens to be more fuel for the sun, making it burn brighter. As the water from Lake Superior is hitting the sun, it's producing more and more hydrogen for the star to gobble up. Could this make our sun explode? Well, not quite. There's already a huge amount of hydrogen in the sun. This is just a tiny drop in a massive ocean. Okay, we now know that a small amount of water can potentially make our sun stronger, but maybe things would be different if we took every little bit of water on Earth and poured it directly on the sun. That's got to put it out, right? Right, guys? Well, to make this happen, you're going to have to drain the oceans. They make up 97% of Earth's water. And you're not going to bother with starships and tanker trucks or even a hose. You're going to build a portal from the Earth to the sun. Let's fast forward how we get to this technology and start building. We start at the deepest spot in the ocean, Challenger Deep, 11 kilometers below sea level. It's situated in the Mariana Trench. It's pretty hard to construct anything down there. The water pressure is intense. It's more than 1,000 times the pressure at sea level. So we'll just make a portal that's 10 meters wide. But with a portal this size, it's going to take hundreds of thousands of years to drain the ocean. At this rate, the water level will drop by less than 1 centimeter per day. The problem is that the ocean is just so large and this hole is just too small. Okay, so let's make this hole wider, or dig a few more portals and arrange them at different spots over the sun. Right, now all the water from Earth's oceans is draining out and getting poured over our star. You get a new readout from the Parker probe. What's happening 150 million kilometers away? Not much. So, what is the Parker probe getting this right? All that water you drained out, all of it, vaporized as it got closer to the sun. The extra hydrogen increased the sun's mass. But even now, with all the water from all the oceans on Earth, the sun's mass has increased just a tiny, tiny amount. Because even though that was a lot of water, it was only 0.02% of Earth's weight. Think about it, the sun has 330,000 times Earth's mass. So that amount of additional hydrogen, nothing more than a splash of fuel for the sun. Ugh, now you've used up all the water in the oceans for this experiment. Our blue marble is looking pretty brown. What's gonna happen to Earth? Things are now a disaster on our home planet. The oceans are now a mass graveyard. Millions of fish, big and small, from tiny plankton to massive sharks, are all dead. All because you wanted to see if you could douse the sun. Humans are in an absolute state of panic. They're frantically calculating how much water is left in the icebergs and in freshwater lakes. How long can that sustain the planet? Thank heavens you left 3% of the water behind. That's 11 million cubic kilometers, and we humans use about 5,000 cubic kilometers a year for all our activities. But wait a minute, we don't melt icebergs for water, we use groundwater and fresh water. So scratch that 11 million, the fresh water in the lakes is just 93,000 cubic kilometers. That won't even last 20 years. Plus, it's getting super hot. With the oceans dried up, water isn't able to play the important role it does in our climate. There are no ocean currents to carry heat away and spread it across the globe. No place for all our carbon to go. Total disruption of our cycle of rainfall. Forest fires everywhere. With rain cycles disrupted, plants will die out and animals will follow. It's a climate crisis, an ecological crisis, and a water crisis all happening at once. I guess the problem we were trying to solve initially got even worse with our efforts. Temperatures would rise to 67 degrees Celsius. That's 150 degrees Fahrenheit. If humans are to survive this crazy heat, we're going to have to change our way of life drastically. Hide out in Antarctica or live in underground bunkers. The grim reality would be that without oceans to get a water cycle going and without plants, life on Earth would be over. Still, on the bright side, you did find out that throwing all this ocean water at the sun won't extinguish it. Guess that's something. Science, yay. Okay, Earth is a mess, but you're still curious about one thing, and you have one last move you want to try. And now it's so hot that you think it's worth it to get the sun to cool down just a little. What if you threw a ball of water the size of the sun at our sun? What would happen then? I know, that sounds nearly impossible. Where would you get a sun-sized ball of water from anyway? Well, I'm not sure. There's definitely not that much water, even if we collected all the H2O in our solar system, because the sun has 99.8% of the solar system's mass. But let's assume that somehow we got this massive ball of water together. Before we get to the sun's reaction, let's look at this giant ball of water. It contains about 1 billion times all the water that's currently on Earth. I mean, that was on Earth before you drained it away. Since water is in contact with space, something weird happens on the surface. In the vacuum of space, there's zero pressure, so the water boils, becoming water vapor. But then, because the temperature is so low, the water vapor freezes almost immediately into ice crystals. If you look at this big ball of water in the sky, there'll be a huge vapor cloud around it as this evaporation and freezing happens. A ball of water this big will also exert a huge amount of pressure on its core. As a result of this intense gravitational pressure, it'll begin to collapse in on itself, and as the pressure in the center increases, the temperature will rise. Under high pressure and high temperature, water molecules in the core might start moving very fast and breaking apart into hydrogen and oxygen molecules. As the hydrogens slam together, they fuse to form helium, releasing energy in the process. And the release of energy further increases the temperature and speeds up the fusion process. Finally, this giant water ball itself becomes a sun, powered by nuclear fusion in its core. Great, I always wanted to have two suns. But another thing might happen. The pressure inside the water ball, though very high, might not be sufficient to start the fusion process, so the ball could become a brown dwarf, which is a failed star. What would happen to our sun? Well, if this giant water ball were right next to our sun, then it may have finally met its match. This water ball would have a mass much greater than the sun, because it's the same size but made of water, and water is much denser than hydrogen. The sun will spiral into this huge water twin and get stretched out in the process. This stretching out of the sun could disrupt the core where all the hydrogen fusion takes place. If the pressure drops, this could slow the fusion process down for a while, but as the two suns come together, it could speed back up, creating an even stronger and hotter sun. Darn it, so is it impossible to disrupt the sun? Well, there's one more thing to try. This is that last trick up your sleeve. It would be to somehow break the sun apart. Instead of just placing them side by side, what if the water sun and our sun met in a massive head-on collision? If that were to happen, just like in planetary collisions, the two suns would split into smaller pieces for a while. A huge vapor cloud would form with smaller but still very big clouds of hydrogen and water. The high pressure at the center of the sun would be disrupted, which would stop the fusion process. Then the pieces would condense again, potentially creating an even bigger sun. When the water sun and our sun crash together, coming apart and rejoining, does Earth get spared the apocalypse? No. Sorry, if anything, the introduction of another giant mass at the center of our solar system would alter the entire gravitational field. The orbits of all the planets would be disrupted, not just in our solar system, but beyond. Sorry, Proxima Centauri, your orbit will never be the same again. Earth, already drained of its oceans, dry, hot, devoid of plants and animals, gets one last kick. We're pushed out of our orbit. That for sure would be the end of life on Earth. So, no, you can't eliminate the sun with water. But what if we tried dumping our trash into it? What would that do? Well, that sounds like a story for another What If.